Here we are, part 2 of the A3 notes. We're going to be doing factoring, so it's really just the reverse of FOILing. What you should know is that it's really kind of the identifying the second part. You guys see these notes from last time. Here we're identifying this part, and we're going to this side of the equation. So here, anytime that you see two perfect square values, and there's a subtraction sign in between them, kind of like if you had x squared minus 4, you would be able to factor that into the first term plus the second term times the first term minus the second term. So a little example, if you had x squared minus 4, you would be able to factor that into x plus 2, x minus 2. Here, anytime that you identify two squared terms and then twice their product on the inside, you can factor that into just the perfect quantity of u plus v squared. A quick example, if you had x squared plus 12x plus 36, here 36, the square root of that is 6, x, the square root of x squared is x, and then 6 times 2 is 12. So here you can factor that into x plus 6 quantity squared. Here, if you could change this to a plus sign right here. Anytime here we have the perfect squares, again, first and last term, and then negative 2 times their product on the inside, that will factor into u minus v squared. A quick example, x squared minus 12x plus 36 is going to factor into x minus 6 squared. And you can double check if you want to FOIL this out to see if you get that, then be my guest. You can pause the video and see if it works out. Some other factoring that you might not be as familiar with are the sum or difference of cubes. Here we have three, two perfect cube terms. You would factor this into the first two terms, so u plus v. Then the second part is going to be the first term squared minus the product plus the second term squared. Here, if we have the difference of two cubes, just like the previous one, you're going to have the first two terms, but this time you're going to take the difference of those, and then it's going to be the first term squared plus their product plus last term squared. So again, we're going to go through and see if we can identify what property it goes with. Always look at the degrees. Hopefully that'll help you get started. For example, this is x to the third, so it's probably going to be one of these. It has a subtraction sign in between it, and then you can just double check. If you take the third root of 27, you're going to get 3. And then the cube root of 1 is itself, it's 1. All right. So sometimes I like to just say, okay, then that means that this first term, the u term, would be 3x. And then the cube root of the second term, we'll call that the v term, is going to be 1. And then you can just kind of place it into the second part of this property. And I guess it's this one because we're using subtraction. So this is going to be 3x minus 1. 3 squared is 9, so this is going to be 9x squared plus 3x plus 1. And here you have it. It's all factored out. Let's see. Next one, I don't know if it's written right. I'll come back to this and do this one in class, okay? Here, part C, we have the difference of two squares, so we can kind of identify what it goes with. It's the first quantity squared minus the second quantity squared. It's probably going to go with this property up here, the first one. All right, I'm going to keep that down so you can see it. So if we follow this FOILing method, it's going to be the first term plus the second term, the first term minus the second term. Here, x plus 2 is our first term. Our second term is y. So it's just going to become x plus 2 plus y. And x plus 2 minus y. You really don't need the extra parentheses in there, so you really could just write it like this, x plus 2 plus y, and x plus 2 minus y. This next one, we only have 2 terms, so it's either going to be one of these right here, or the first one. Just double check, 81 is not a perfect cube. It is a perfect square, right? 9 times 9 is 81. 16 is also a perfect square. If you were to square root x to the 4th, you would get x squared. So if you want to use the U and V method, let's see, just square root the first term, you're going to get 4x squared. Square root the second term, you're going to get 81 is 9. So following the second half of the first property, we're going to have 4x squared plus 9 and 4x squared minus 9. This is kind of special because the second part is also the difference of 2 perfect squares. So let's go ahead and factor it one more step. So let's see, the square root of 4x squared is 2x, so this is going to become 2x plus 3, 2x minus 3. E and F are a little bit different. We're going to be removing a common factor, which means that you're going to be looking at the first part of your polynomial and the second part. See if you can move common factors, common variables. For example, 3 and 12, you can both factor out a 3 from both of those terms, leaving you with 1 minus 4x squared in there. And actually, this is the difference of 2 squares, right? The square root of 1 is 1, the square root of 4x squared is 2x. So you could go ahead and factor it so that it would become 3 times 1 plus 2x, 1 minus 2x. So just work on identifying perfect squares, perfect cubes, because you can really take these a lot farther if you're able to identify them and use the properties listed up here. Part F, I know it's a little bit harder to see this. Again, it's still just looking at both the front term, so I guess whatever's in front of the plus sign and whatever's behind the plus sign. Identify if anything's the same. Here, this x minus 2, you have that both in the first part of your expression and in the second part of the expression. What that means is that you can factor 1 out, and then you're left with everything else inside parentheses together. So here we're going to factor this out. Just like we factored 1, 3 out, we're only going to factor out 1x minus 2, leaving us with the leftovers of 2x plus 3 on the inside. I can definitely go over that one. I found that in the past a lot of my students have questions about this one in class, so we can maybe do some more examples. Just remind me if you need to, okay? The last couple we're just going to be factoring by grouping and just regular factoring. Here we're going to factor a trinomial. And this is probably what you are the most proficient at. I guess quick steps are on the side. What I would say a good way to get started, you can take the last term and think of factors, so numbers that multiply to get negative 16. So we could have 1 and negative 16, negative 1 and 16, 3, negative 4, 4, negative 3. And then you just, oh, whoops, what am I thinking? 12. 8 and 2. I apologize. So 2, negative 8, and then positive 8, negative 2. And then just double check which of these add to get the middle term. So we're looking for negative 6. If you add 2 and negative 8, you're going to get negative 6. So these are going to be the factors that you use, which kind of helps when you break it apart into your two binomials. You can just keep the signs that go with them. For example, 2 is positive, so this is going to become plus 2. 8 is negative, so it'll become negative 8. It's factored. The next part I really like is factoring by grouping. Really, you just take the first two terms and factor out what you can from them. For example, let's see, x squared and 2x. We can factor an x out, leaving us with x minus 2 on the inside of the parentheses. The idea is to factor out something from the second half so that you end up with the same quantity after you factor. So for this next part, I'm going to factor out a negative 3, leaving us with x minus 2. This is actually the same idea as f, so if you didn't quite get it on part f, you can see if you can identify it here. We are looking for something that's the same in the first part of our expression and in the second part of our expression. It's going to be divided by the subtraction sign. So if you look before the subtraction sign, we have an x minus 2. And after the subtraction sign, we have an x minus 2. You can factor out 1 and put the leftovers together in the second parenthesis. And it's all factored. You can FOIL it to see if it works out. We're going to use grouping for this next one. It's a little bit different. Some people can see this and just factor it right away. If you're one of those people, excellent. Keep doing what you're doing. If you need a little bit help when you factor terms with a multiplier in front of your leading, or just anything with a leading coefficient other than 1, one trick that you can do, just take the first and last terms and multiply them. So here, 2 times negative 3 is negative 6. And then do the same idea. What are the factors of negative 6 that are going to add to get to 5? Well, 6 and negative 1. If you add those together, you're going to get 5, right? So what we're going to do, or what you can do, is split this apart, this 5x, so that it's written as 6x minus 1x. And you can see it stays equal. It doesn't matter which one you put where. I'm going to put the 6 with the 2 just so it's a bigger number. So we're going to have 2x squared plus 6x minus x minus 3. And then use factor by grouping. Out of the first two, we can factor out a 2x. X plus 3. Out of the second two, we can factor out a negative 1. Again, x plus 3 is in the first and second part, so you can factor 1 out. And then the leftovers go together in the second quantity. And there you have it. There's some factoring. Please rewind, rewatch, and you can start working on your reflection sheet. Thank you.